press the bell icon on the YouTube app and never miss another update.
Hi, hello, good afternoon, everybody. So, we were studying the chapter called as Organisms and Populations, right? So, in that, we were studying the various aspects of the ecological properties, and we were studying the various responses to the abiotic factors. So, we studied the various types of response to abiotic factors by the organisms. The first one we studied was regulators, we studied conformers, we also studied suspend and also migration in organisms. How organisms respond to stressful conditions in the abiotic factors or stressful conditions in the habitat. Now, moving on to the next topics, we also studied about adaptation, how organisms live successfully in its habitat and reproduce. And now coming to the other aspects. Yesterday we started with populations. So we started with population, we studied the various properties of a population like the birth rate, the death rate, and also the sex ratio. So we had stopped at age pyramids. So we will continue with age pyramids. So age pyramids or the graphical representations of, they are nothing but the graphical representations of various groups of various age groups in human population or in population in populations. So these age pyramids are of three types. There might be an age pyramid which is of expanding type, So we have three population groups like pre-reproductive age group, reproductive age group, and post-reproductive age group. So this is pre-reproductive group. So this is reproductive group and this is post-reproductive group. So this is called as an increasing type of population. I'll come to that later. So let me finish the diagrams. So this will be usually a triangular type of age pyramid, which comprises of the three groups of population. One is called as the pre-reproductive population, reproductive population, and post-reproductive population. So increasing type of population, which is represented by a triangular pyramid, And we have another type of age pyramid, which is for stable population, where the pre-reproductive population is at the base. The base of the age pyramid is formed by the pre-reproductive population, which is followed by the reproductive population and the apex is formed by the post-reproductive population. So the pre-reproductive at the base of the age pyramid Then the reproductive population, it is reproductive population, and finally it is post-reproductive population. So yesterday we have already discussed what is pre-reproductive population, what is reproductive population, and what is post-reproductive population. And here almost the pyramid is of bell shape. It is of the bell shape. So bell shape of age pyramid is seen, which shows that the population is stable in the future years. So here we can see that the population goes on increasing in the future years, whereas this population age pyramid tells that in the future the population size is going to be stable, or we have a stable population size. And here this is the bell shaped age pyramid, the base which is represented by the pre-reproductive population. In the middle, we have the reproductive population, and in the apex, we have the post-reproductive population. Yes, you can see that this is triangular shaped pyramid, whereas here we have the bell shaped pyramid, and here on the third, we have another type of age pyramid which is represented in the base. We have the pre-reproductive population, which is a symbol of declining population, which is a symbol of declining population. Pre-reproductive population at the base. So reproductive population in the middle, and post-reproductive population on the apex, on the top. So this is a population which is showing that in the future years there will be a decline in the population size. So this is an urn shaped. This is an urn shaped So this is an urn shaped population age pyramid. So in the base we have the pre-reproductive population. In the middle we have the reproductive population, and in the top you have the post-reproductive population. So which is of urn-shaped age pyramid. Urn-shaped age pyramid. So this is the age pyramid which is of triangle shape, where we find an increasing type of population size in the future years. So in the future, we find that the population size goes on increasing. And here we have the bell-shaped age pyramid where the base is broader, and in the future, the same population will be maintained in the future years, which is called as the stable population. And in the third, we have the declining population age pyramid, which is of urn-shaped. And here we can observe in the future years, the population size is going to decrease. So the decrease or increase in the population size depends upon the pre-reproductive population. So the pre-reproductive population is the one which is going to enter into the reproductive group in the future years. So when the number of the pre-reproductive age group is very less, so obviously in the future there is a chance of decline in the population size. So if the pre-reproductive population is the number of or the population size of the pre-reproductive population is high, then the expected is in the future years there will be an increase in the population size. So with these aspects, let us some important neat questions will be asked in this particular topic about the post-reproductive, reproductive and pre-reproductive. So based on this graphical representation and also shape of the age pyramid. So age pyramid is a graphical representation of various age groups in a population, in which the base of the pyramid is formed by the pre-reproductive population, the middle is formed by the reproductive population, and the top is formed by the post-reproductive population. In that, we have three types of age pyramids. One is the increasing age pyramid, which is of triangular shape. Another is the stable population, which is of bell-shaped, and the other is of declining population, which is of urn-shaped. So regarding all these shapes and aspects, the question will be asked in the NEET examination. So remember the diagrams, remember the graphical representation, and remember which group, whether pre-reproductive population is at the bottom or at the top. So based on all this, you might have some questions in the NEET examination. So now looking on to the next topic, that is population density or population size. So next topic is population size or population density. So now coming to population density. Simply, which is represented as capital N. So the population size can also be called as the population density. The population size can also be called as the population density. So the population density may be very less than like there might be Siberian cranes and a pond like very less number of cranes, which is telling about the population density is very less. There may be thousands of chlamydomonas in a pond, which tells the population of chlamydomonas in that particular pond is very high. So like this, the population density may be very high or the population density may be very less. So this population density depends upon the death rate and the birth rate. It depends upon the birth rate and the death rate. So in the last class, we have studied about what is birth rate and what is death rate. And we also understood the calculation, how to calculate the birth rate and the death rate. So here, always the population density is exactly telling the population density may be the number of exact count of the population. So like human population is made every 10 years once in India, and population count of each and every individual is taken into consideration, which gives the absolute population density. But many a times population density cannot be studied in this form. So the population density cannot be an absolute value in many of the cases. So there might be some relative densities studied, relative population densities that can be studied. So in relative population density, what happens is, so the population size, the taking a individual count of the population may not be possible. Taking the individual count of the population may not be possible. So that may lead to in such cases, instead of the absolute value, relative population density is taken into consideration. So the best example is, so if you put a net, if you try to trap fishes in a net in a pond, and if in a single trap, if you are getting huge number of fishes, then you can call the population density of the fish in the pond is very high. So this is what is called as relative population density. ಸೊ ಒಂದು ಪಾಂಡ್ ಇದ್ರೆ ಆ ಪಾಂಡ್ ಒಳಗಡೆ ಇರುವಂತಹ ನಂಬರ್ ಆಫ್ ಫಿಶಸ್ ಅನ್ನ ನಾವು ಕೌಂಟ್ ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಸೊ ಇದು ವೇಸ್ಟ್ ಆಫ್ ಟೈಮ್ ಮತ್ತೆ ವೇಸ್ಟ್ ಆಫ್ ಎನರ್ಜಿ ಕೂಡ. ಸೊ ಅದ್ರ ಜೊತೆಗೆ ನಮ್ಗೆ ಅಬ್ಸಲ್ಯೂಟ್ ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ ಅಂತ ಏನು ನಮ್ಗೆ ಗ್ಯಾರಂಟಿ ಕೂಡ ಇಲ್ಲ. ಅಂತಹ ಸಮಯಗಳಲ್ಲಿ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಡೂ ಇಸ್ ವಿ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ದ ರಿಲೇಟಿವ್ ಸ್ಟಡಿ ಆಫ್ ದ ಪಾಪ್ಯುಲೇಷನ್ ಡೆನ್ಸಿಟಿ. ಐ ಹೋಪ್ ಯು ಆರ್ ಫಾಲೋಯಿಂಗ್. ಸೊ ಅಂತಹ ಸಮಯದಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ಬೋದು, ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಅ ಸ್ಟಡಿ ಆಫ್ ದ ರಿಲೇಟಿವ್ ಪಾಪ್ಯುಲೇಷನ್ ಡೆನ್ಸಿಟಿ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಕರಿತೀವಿ. ಸೊ ರಿಲೇಟಿವ್ ಪಾಪ್ಯುಲೇಷನ್ ಡೆನ್ಸಿಟಿ ಅಂತಂದ್ರೆ, ಒಂದ್ಸತಿ ನಾವು ನೆಟ್ ಹಾಕಿದಾಗ ಪಾಂಡ್ ಅಲ್ಲಿ ಒಟ್ರಾಶಿಯಾಗಿ ಆ ನೆಟ್ ಅಲ್ಲಿ ಎಷ್ಟು ಮೀನ್ಗಳು ಬರುತ್ತೆ ಅದ್ರ ಮೇಲೆ ವಿ ಕ್ಯಾನ್ ಡಿಸೈಡ್ ದ ಪಾಪ್ಯುಲೇಷನ್ ಡೆನ್ಸಿಟಿ ಆಫ್ fishes in that particular pond is whether it is high or low or moderate, like this. So which is called as relative population density. So sometimes when we are comparing some organisms with other organisms, population density, for example, now population density of Parthenium is taken. If the population density of a single banyan tree in the same area, single banyan tree in a particular habitat, let me hope there are 200 Parthenium plants and there is one big banyan tree, one big banyan tree. So if we are speaking about the population density, so it is an injustice for the single banyan tree which has got a huger biomass and it is of higher value, right? Higher potential value when compared to Parthenium, which is considered as a weed. So in that case, we speak about percent cover or biomass. In such cases, we use the word percent cover or biomass is taken into consideration. So the biomass of the banyan tree is much higher when compared to the 200 Parthenium plants. So maybe the number of Parthenium plants are more, but comparatively, this banyan tree has got more value in its community when compared to the Parthenium, which is a weed. So in such cases, we speak about percent cover or biomass. So there are various methods of making a calculation for population density. So for example, taking the absolute number of the population. So counting the individuals, 1, 2, 3, like that. For example, the human population is taken like that. So there are almost 6 billion human beings in India approximately, according to the earlier census. So population density keeps on varying also. Let us come to that aspect later. So this population density, either you can take the absolute values by like making a count of each and every individual, or you can calculate the population density like relative population density, where you can make an approximate calculation, where you can make a approximate calculation, as I told you the example of fish in a pond. And here we can also make a population density study by percent cover or biomass. So these are the various ways of measuring the population density or calculating the population density, whichever population it may be, if it is human population or any fish population or the Parthenium population or the banyan tree population or whatever population it is. So all these different types of studies are made to calculate the population density of a a particular population in a particular period of time and in a particular habitat, in a particular period of time and in a particular area or particular habitat. So that is about the population density. So this population density is not always a constant. So it keeps changing. So it depends upon the various factors on which it is dependent upon. For example, the population size may keep on varying. So what are those factors that affect the population density or the population size? So let us come to the point called as population growth. Population growth. So population density depends it is affected by the various abiotic factors and the biotic factors. So the various abiotic factors and the abiotic factors influence the population density, will influence the population density. For example, the population size depends upon the availability of food, which is the basic essential for any population. Availability of the food. Availability of food. The second is predation pressure. Predation pressure and climate. And climate. So all the three will influence the population size. So the population size is affected by these three aspects, that is availability of the food, predation pressure and also the climate. If in a particular habitat there is abundant of food, that is the resources which are essential for an organism or for the population to grow, then there might be an increase in the population. So if there is no adequate or optimum levels of food or adequate food available for the populations, then the population may decline. Then if there is more of predators in that particular habitat, so obviously there will be an increase in the population. So sorry, there will be a decrease in the population. If there are if there is less of interspecific competition or predation pressure or the predators are less in number, obviously there will be an increase in the population size. Likewise, the climatic conditions. So if it is highly raining, it is severe hot, severe winter, or it is rainy season, or it is severely raining, all these are various conditions which will affect the population size. If there is severe rain and floods, then there may be decrease in the population. So many of them may lose their habitat and they cannot withstand the pressure of the climate and they may die. So if there are heavy floods, if there are heavy famines, the organisms may not get food and shelter and they may die. So all these are various factors that will affect the population size and bring about a change in the population growth, which may bring the change in the population growth. Of course, population density is not static. It is not a constant. So it keeps varying. So population size may increase or may decrease. So right now, because of the pandemic situation like corona, we can see there might be a decreasing type of population. Every day, every day population is decreasing in Davangere, like 2 or 3 people are getting susceptible to corona, additional to the usual death rate, right? So there might be decrease in the population size and thereby the climatic conditions which contains even the atmosphere which contains the various harmful microbes may also affect the population size. So that is about the three factors. So now coming to what are the three basic processes that affects the population size or the population density. So the population density is altered or affected with the help with four important basic principles. So it keeps fluctuating. The population density keeps fluctuating because of four basic processes. Four basic processes brings about a fluctuation in the population density. So the first one is natality. Natality. The second is mortality. The third is immigration. And the fourth is emigration. So these are the four basic processes, so which will influence the population density, which may bring about a lot of fluctuation in the population density. So population size is simply referred as the population density, and it is denoted as capital N. So the first one is natality. So what is natality? In simple words, you can also call it as the birth rate. In simple words, natality can also be called as the birth rate. It is the number of individuals that are added to the population in a particular time, in a particular habitat, is called as natality. So by new births, so some of the population is added, some of the individuals are added to the population, thereby they bring about an increase in the population size, right? So some of the new individuals are added by the process called as birth. So the birth rate will increase the population size, which is called as natality in a particular period of time in a particular place. So in a particular habitat and in a particular given period of time. The second one is mortality. So mortality refers to the death rates. So death rate, the number of individuals which undergo death in a given period of time in a particular habitat is called as the mortality. So the death rate can be called as the mortality. So here there is this mortality brings about a decrease in the population size. So mortality brings about a decrease in the population. So next is immigration. Immigration is so many people from urban areas, so from rural areas, from the districts, from the rural areas of Davangere may migrate to Davangere. So the individuals coming into the habitat from elsewhere. So individuals coming or migrating from elsewhere into the habitat, or the individuals coming into the habitat from elsewhere is called as immigration. So many of the people from their rural areas may enter into the Davangere city, which may increase the population size of Davangere, which is called as immigration. So emigration. So emigration is the movement, the individuals move from particular habitat out of the particular habitat to elsewhere. So many people may move from Davangere to Bangalore or to different countries outside India. So which may decrease the population, and the process is called as immigration. Emigration. It is called as emigration. So immigration is individuals which are added to that particular habitat who come from elsewhere, and emigration is going out of the habitat to elsewhere. So coming into the habitat from elsewhere is immigration, and going out of the habitat to elsewhere is emigration. So all these are four different basic processes which brings a which alters the population size or the population density. So here what we observe is natality will add some individuals to the present population, and immigration will also add some individuals to the present population. Therefore, they natality and immigration bring about an increase in the population size, whereas mortality and emigration. So during mortality, the number of individuals are lessened in a particular habitat, and during emigration also, because the individuals move to elsewhere from that particular habitat, there will be reduction in the number of individuals, thereby decreasing the population size. So natality and immigration will increase the population size of a habitat, whereas mortality and emigration will decrease the number of individuals or decrease the population size in a given habitat. So these are the four basic processes that will alter the population density. So there is a diagrammatic representation to show all these basic processes. We will try to write that diagram because that is very important from our NEET exam point of view. So this is population density, which is denoted as capital N, which is denoted as capital N, which is denoted as capital N. And population density is influenced by the four basic processes like natality. So because natality is birth rate, let us represent natality by the letter B. Population density is denoted by the letter N and natality is represented by the alphabet B. So natality will add the individuals to the population density. Therefore, I am writing a plus mark. So some of the individuals are eliminated from this habitat, that is the population density decreases due to elimination of some of the individuals by the process called as mortality. By the process called as mortality. And mortality means death rate. Therefore, we can represent mortality with capital D. We represent mortality with capital D. And one more process is immigration. Immigration. So immigration adds the individuals to the population and it is represented as I. So which will also increase the population density or it will add the individuals to the population density. And here we have another process which is called as the emigration, which is called as the emigration. Which is called as the emigration, which is represented as capital E, which is represented as capital E, and individuals are lost uh, from the particular habitat as there is a movement of individuals from that particular habitat to elsewhere in emigration. So, natality and immigration will bring about the increase in the population size, whereas mortality and emigration will bring about the decrease in the population size. Will bring about the decrease in the population size. So that is the diagrammatic representation. So this the same diagram may be asked for you in the NEET examination. This may be given as A, B, C, D. These signs may be given as A, B, C, D, or even this I, B, E, and D can be given as the options, and they may ask immigration, natality, or immigration or mortality, and may put it in blank and ask to fill the options. So remember this representation, very important from exam point of view, right? So this is how the population density is alters with the basic forces like natality, mortality, immigration and emigration. Now this population density at given time t can be denoted as, so the population density at given time t is denoted as is equal to n t plus 1 is equal to n t into b minus d, sorry, b minus d minus, sorry, b plus i, b plus I minus d plus e. So the population density at given time t can be denoted as b plus I minus D plus E. B stands for birth rate, I stands for immigration, D stands for death rate, and E stands for emigration. So NT is population density at time t, density at time t. So B refers to birth rate or natality. I refers to immigration rate. D refers to death rate, and E refers to emigration rate. Emigration rate. So B plus I. So birth rate and immigration will increase the population size. So in that you are going to minus the amount of deaths or the individuals that have died and the animal and the individuals who have gone elsewhere from that particular habitat. So B and I will add individuals to the population in a particular habitat, whereas D and E will remove the individuals from the population in a given habitat. So this is about what is called as population density. So population density can always never be a constant. It keeps altering. So the altered population density is because of these basic four forces called as natality, mortality, immigration, and emigration. So next, we'll move on to the next topic. So after population density, we are going towards growth models. Growth models. So any population can grow when there is availability of the basic necessities. So availability of the basic necessities, the influence of the biotic and abiotic factors also brings about the growth of the individuals. So if there are, so we have studied the various abiotic and biotic factors. So the four abiotic factors are the temperature, the light, water, and soil. If there is abundant of soil or highly nutritious soil, then it will increase the productivity. If there is more of productivity, there is abundant of food. If there is abundant of, excuse me, if there is abundant of food, so abundant of food and space, therefore there is lot of uh, chances for increase in the population of in a particular habitat. So increase in the size of the population can be easily brought about, can be promoted. So growth models, we have two types of growth models. So the space, the food, or the basic essentials for any of the organism. If they are available and abundant, obviously there might be a increase in the growth of the population. So if there are more of pathogens or adverse climatic conditions, all these are certain things which may put down the population size, as we have already discussed. And growth models, these growth models, we usually we have two different types of growth models. One is called as the exponential growth model, and the other is called as logistic growth. Exponential growth or the logistic growth. Exponential growth or the logistic growth. So the growth depends upon the death rate and the birth rate. So birth rate and the death rate influences the growth. So birth rate and death rate here, per capita birth rate and per capita death rates. The influence of the per capita birth rate and influence of the per capita death rate is taken into consideration during the study of growth of any population. So population growth can be of two types. One is called as exponential growth and the other is called as the logistic growth. So each of which we will take in detail and try to understand what is exponential growth and what is logistic growth. So to start with, exponential growth. Exponential growth. So in exponential growth, what can happen? So when the resources are abundant, this can take place only when resources are abundant. So what does the resources refer to here? So resources refer to the food, shelter, breeding place and breeding partner. So breeding place and breeding partner. So all these is called as resources. When the resources are abundant, then the growth of a population can occur in geometric ratios. The growth of the population goes on increasing in geometric ratios. How can you tell what is the meaning of this? How it increases in geometric ratios? Like 1 can plus 1 becomes 2. So 2 plus 2 becomes 4. 2 plus 2 becomes 4. 4 plus 4 becomes 8. 8 plus 8 becomes 16. 16 plus 16 becomes 32. So if this goes on, then you call that as increase in the population in geometric ratios when there is abundant of resources. When there is abundant of resources. And this exponential growth can be calculated with the help of per capita birth rate and per capita death rate. So how can you calculate? So a simple example, simple illustration has been given in your textbook with the help of a small story like there is a bet between the king and the minister. So the king challenges the minister. So when he, if at all, he in a game of dice and he loses the game and he asks the minister gives a puzzle to the king. He asks all the in the game of chess in the all the 64 squares should be filled with wheat grains in geometric ratios. So the king thought it's a very easy job for him. He started with the first square, he filled it with one wheat, second with two wheats, third box with four wheats, fifth with eight wheats. Like this, it went on. By the time he filled the half of the squares, he came to know that it is highly impossible for him to fill all the 64 squares, and because here the increase in the number goes on in geometric ratios. So if you assume an organism which goes on increasing in geometric ratios, so the population increase is in a very faster rate. The population size goes on increasing in a very faster rate. For example, this can happen in the same type of increase in the population can happen with chlamydomonas. So chlamydomonas, or even if you take amoeba, which will undergo binary fission, right? So it will undergo binary fission. So one will divide into two, two will divide into four, four into eight, 8 into 16, 16 into 32. So this goes on and the population goes on increasing in geometric ratios, which is called as the exponential growth. We call this as the exponential growth. And this exponential growth can be represented with the help of a graph. So a graphical representation can be made for the exponential growth, and we can also put an equation for the calculation of the exponential growth or to find out what type of growth the population shows. So let us see what is that equation and also the graphical representation for. So the population density and population growth at a particular time t, in a given time t, dn by dt you can write it as. So population growth in a given period of time can be written as dn by dt is equal to, so b minus d, I told you b stands for per capita birth rates and d stands for per capita death rates into n. So b minus d, so b is per capita death, per capita birth rate, and d is per capita death rate. And capital N is equal to population density. Population density. So now B minus D is represented as R, which is called as R value, which means intrinsic rate of natural increase, which is called as R value. So B minus D represents R, which is called as intrinsic rate of natural increase. That is the inner potential of an organism to increase its number is valued in terms of R values, which is called as intrinsic rate of natural increase. So once again, the exponential growth can be calculated using this formula, or this equation can be used to represent the exponential growth curves. So dn by dt is nothing but the population size at a given population growth for a given period of time t. So dn by dt is equal to b minus d, where small letter we have written b and d. So small b represents the per capita birth rate and small d represents per capita death rate, and capital N is nothing but the population density. So B minus D is represented by R, which is nothing but the intrinsic rate of natural increase, which is nothing but the intrinsic rate of natural increase. So this can also be written in the integral form also. So if you are writing it in integral form, so it is nt is equal to n naught, sorry, nt is equal to n naught e to the power of rt. So where nt is equal to population density at given time t, n naught is population density at time 0, and e is natural base of natural logarithms. You can also, you better write it as base of natural logarithms, base of natural logarithms, that is 2.7182. So and R is nothing but the intrinsic rate of natural increase, intrinsic rate of natural increase, and t is equal to time. T is equal to time. So n naught e to the power of rt also represents the exponential growth, where the growth occurs in geometric ratios, and there is a fast increase in the population density. So exponential growth can be represented by two important formulas. This is the calculus form and that is the integral form of the equation. So in the calculus form, it will be dn by dt is equal to b minus d into n, where b minus d can be replaced by r. So dn by dt will finally become is equal to Rn, right? Where R is the intrinsic rate of natural increase and N is population density. So in integral form, it is Nt is equal to N naught e to the power of Rt. So where N naught is equal to population density at time 0, and E is base of natural logarithms, which is equal to 2.7182, and R is nothing but the intrinsic rate of natural increase, and T is equal to time. So this R value or will always have a value. If you know the value of B and if you know the value of D, it is easy for you to calculate the R values. So if B values and D values are known for a particular population, we can calculate the R values for a population. So for example, in the R values for certain organisms are given, like for Norway rat, the R value is equal to 0.015. For floor beetle, the R value is equal to 0.12, and the R value for human population according to the earlier census which was conducted in 1981, the R value is about 0.0205. Excuse me. Yeah. So the R value can be calculated for organisms if you know the value of B and D. So B is the per capita birth rate and D is the per capita death rate. So if we know these values, we can calculate the value of R. So the already calculated some of the values of R are, for Norway rat it is about 0.015, and for floor beetle it is about 0.12, and for human population according to the census 1981 of India it is about 0.0205. So this is about the exponential growth with R values. And now we will write a graphical representation to show the exponential growth, right? So writing a graphical representation of for exponential growth curve. So this is the population density on y-axis, population density on y-axis, and time on the x-axis. So when the resources are abundant, so initially there is a slow growth, and finally the population goes on increasing like this, which gives a J-shaped curve, which represents dn by dt is equal to r n. R is the intrinsic rate of natural increase. So dn by dt is equal to Rn. So this is a graphical representation to show the what is called as the population density versus time for exponential growth model. So you will get a J-shaped model, and human population is right now going in the same pattern of population exponential growth, or it is increasing in geometric ratios. So when the human population growth is studied for whole world, so it is gone increasing like this in the geometric ratios, which can be called as the exponential growth model. So such exponential growth should not happen in the nature. It is quite, it is not a fair part for the nature. It is not fair on the part of the nature. So when the resources are abundant, this happens. But finally, the abundant resources will go on decreasing because of severe competition, which is called as interspecific competition. Which is called as interspecific competition. When the interspecific competition goes on increasing, naturally, once again, there will be a decrease in the population size. So, this type of population is not a realistic one. Therefore, this type of population growth cannot be considered as a realistic one. Then, what is the realistic growth curve? So let's go to the next growth curve, which is called as the logistic growth. So I hope you have understood what is exponential growth. Once again, I shall repeat. So exponential growth can be given with the help of an equation dn by dt is equal to rn, where r can be calculated by if we know the per capita birth rate and per capita death rate. So R is called as the intrinsic rate of natural increase. So that is calculated by B minus D, right? So this type of growth can occur only when there is abundant of resources. This can occur only when there is abundant of resources. So when the resources are less, so we also have written the integral form of the same equation like n t is equal to n naught into e to the power of rt, right? So that is the integral form of this equation. And I had given the R values for Norway rat, it is about 0.015, and for floor beetle means ಹಿಟ್ಗಳಲ್ಲಿ ಮತ್ತೆ ಅಕ್ಕಿ ಕಾಳುಗಳಲ್ಲಿ you find a type of small organism beetle, isn't it? So that is called as floor beetle. So ಅಕ್ಕಿಲಿ ಮತ್ತೆ ಹಿಟ್ಗಳಲ್ಲಿ ಹುಳ ತರ ಆಗತ್ತೆ. So they are called as the floor beetle. ಅದರದ್ದು R value ನೋಡಿದಾಗ it is about 0.012, and the human populations ಗೆ R value ನೋಡಿದಾಗ it is about 0.0205. So that is about the R values. Remember those values which may be asked in your NEET examination. Very important from a NEET point of view. And this is the growth curve. So if you plot population density on the y-axis and time on the x-axis, so the exponential growth, initially there will be a slow growth, and as the growth, and finally the growth goes on increasing and increasing, so which increases in geometric ratios. So this is what is called as an exponential growth. So the graphical representation tells that it is a J-shaped curve. It is a J-shaped curve. So they will ask in the exam. So exponential growth leads to a dash shape of curve. So it is J-shaped curve. It forms a J-shaped curve. Next is logistic growth. So logistic growth curve. So when the resources are limited, when the resources are limited in a particular habitat, limited in a particular habitat. So this type of growth takes place when the resources are limited. There, when the resources were abundant, so that the exponential growth had taken place. But when the resources are limited in a particular habitat, that is called as the that leads to a growth model which is called as the logistic growth, or it is also called as world's logistic growth. It is also called as world's logistic growth curve, named after the scientist. Next, so here we have one more phenomenon which is called as one more property which is called as carrying capacity. Carrying capacity. So what is the meaning of this carrying capacity? And this carrying capacity is denoted as capital K. It is denoted as capital K. So carrying capacity is the maximum. It is the maximum resources that a habitat has. Maximum resources that a habitat has. Sorry, it has got enough resources, you can call it has got enough resources to support maximum growth, which can support maximum growth, which has got enough resources in the habitat to support the maximum growth of a population, which can support the maximum growth of a population. You can call it as the carrying capacity. For example, if there is a room of your classroom size, so you can accommodate a certain number of uh, individuals there. Maybe if it is a very small classroom, it can accommodate nearly 30 to 50 students. If more and more students are put over in the same classroom, there will be severe competition to see the board, or to there might be certain mischievous activities, or there might be hindrance for other students to listen the class. Like this, there will be some sort of competition. So carrying capacity is having enough resources to support maximum growth in a particular habitat. So not beyond not beyond the what maximum growth can happen there. So not beyond the maximum growth can take place there. Beyond the maximum growth, it is not possible as the growth in the geometric ratios. So growth cannot happen in geometric ratios. It will reach a maximum level and then the growth stops or maintains the same maximum growth, or a static growth is maintained. So which is called as the logistic growth. So here we have one phenomenon which is called as the carrying capacity. So carrying capacity is nothing but there are enough resources for to support the maximum growth of the population in a particular habitat. So I have told you resources are nothing but the food and the availability of the space, and the breeding partners and also the breeding place can also be called as the resources, can be considered as resources. So carrying capacity, a habitat has got certain amount of resources which is capable of developing a particular growth of a population to a certain level, not beyond that level. Not beyond that level, as in the case of geometric exponential growth. Not as in the case of exponential growth. So this type of growth is called as world's logistic growth curve, or it is referred as simply logistic growth. So which depends upon the carrying capacity, where the resources are limited in a particular habitat, or there are enough resources in a particular habitat to support a particular level of population. So to support a particular level of population. So which is called as logistic growth. And this logistic growth can be represented with the help of an equation. Let it be there. So it can be represented with the help of an equation called dn by dt. So it is population growth in a given period of time, which is Rn into k minus n divided by k, where R is equal to intrinsic rate of natural increase and n is population density, k is carrying capacity, k is carrying capacity, and that's it. So dn by dt, that is population growth in a given period of time, is equal to rn into k minus n divided by k. So r is intrinsic rate of natural increase and n is population density and k is the carrying capacity. So carrying capacity is the amount of enough resources that a habitat can accommodate to support a particular amount of a particular population. So which is called as logistic growth. And this logistic growth also can be plotted with the help of a graph. So looking into the graphical representation of the logistic growth. So let's take time on x-axis, time t, population density on y-axis, which is denoted as capital N. And now the carrying capacity. Let me draw a line here showing the carrying capacity or the enough resources or the maximum of resources in a particular habitat it possesses. And now look at the growth. Initially there is a lag phase and there is an acceleration of the growth and and finally there is a deacceleration of the growth. So there is a deacceleration of the growth. So initially this is called as a lag phase. So lag phase, accelerated phase, and S phase or senescent phase, it is also called as S phase. Senescent phase, it is also called as, and reaches a state of equilibrium. And the population size cannot go beyond this carrying capacity. So it cannot go beyond the carrying capacity because it is this habitat will have some amount of resources which is completely utilized by the population, the individuals in that particular population, and this will be the type of growth. So if there is still excess growth, there will be natural decrease because of severe competition. With this type of growth is the most realistic one, because whenever there is an increase in the population and there is deficiency of the resources, there will be severe competition, and in severe competition many of the organisms are going to die, or which as explained by Darwin. So Darwin tells prodigality of production. So if there is an increase in the population size and geometric ratios, which will lead to severe competition. So he speaks about two types of competition, like interspecific competition and intraspecific competition. So the competition between the individuals of the same species, you call it as intraspecific competition, and interspecific competition is the competition between the species belonging to other species. So different species is called as interspecific competition. So obviously when there is limited resources, there will be severe competition, and this severe competition, those organisms which cannot struggle hard, they may succumb, or the one which cannot struggle or which cannot fit into which cannot attain the fitness, they are going to die or they are going to succumb, is what told by Darwin. So according to his theory, this growth model works according to his theory of prodigality of production, and we can see that uh, the as a habitat can accommodate maximum amount of resources, and it can support a maximum growth based on the capacity of that particular habitat. So it cannot uh, support growth beyond its capacity, which is called as the carrying capacity. So here in the logistic growth curve, we find the growth curve is of S shaped. So there, in case of exponential growth, we saw a J-shaped curve, whereas here in the logistic growth, we are observing the growth takes place in S shape, where initially there is a slow increase in the population size, and immediately there is an high increase in the population size, and finally there is the growth rate goes on decreases and maintains a uh, constant growth, which is called as the as it reaches the carrying capacity. So the maximum the carrying capacity, the maximum that particular habitat can accommodate, so much of population can increase, not beyond that. So if it goes beyond it, there will be a natural decrease due to severe competition, that is interspecific competition and intraspecific competition. So the nature always tends to keep the population in a constant. In spite of that, the human population is increasing with to a alarming densities, so which is quite dangerous. Anyhow, so this is the logistic growth curve, which is more realistic than the exponential growth curve. So here, when the resources are limited, or which is almost enough to maintain a particular size of population, is called as the carrying capacity. So this is the equation. So the dn and dt represents the uh, growth of population density, and r is representing the intrinsic rate of natural increase, n is representing the population density, and k is representing the carrying capacity. So this is logistic growth curve, which is of S shape. So which is the more realistic type of growth when compared to the other type of growths. So now looking into the next topic, which is called as life history variations. This is a very small topic, and after this I shall end this session. So the next one is life history variations. See, populations evolve maximum to their reproductive fitness, maximum to their reproductive fitness, which is nothing but the R value, which is nothing but the R value. So any organism in the course of the process of evolution becomes more and more, evolves into a much stronger species that it can permanently stay on the earth with lot of uh, with increasing population, and makes its progeny stable on the planet earth. So which is called as reproductive fitness, and which is almost maximum, which is almost maximum. So this is what is called as reproductive fitness. So the organisms live successfully and reproduce successfully in spite of varying abiotic factors and also varying very severe competition among the biotic factors. In spite of the various biotic factors like the pathogens, like the competitors, like the predators, like the parasites, in spite of their presence and in spite of varying abiotic factors, the organisms survive and reproduce successfully and continue their progeny, which is called as reproductive fitness according to Darwin. And this reproductive fitness is nothing but the R values, which is calculated by birth rates, per capita birth rate and per capita death rate. So organisms have evolved into different strategies. The organisms or the populations have various strategies to attain this reproductive fitness. So what are those strategies which we see in the various populations? So the primarily in some populations they reproduce throughout the year, reproduce throughout the year, whereas some reproduce once in a year, once in a year. So the populations which reproduce throughout the year are, one is the mammals and the other is birds. And the other is birds. So once in a year we have reproduction can be seen once in a year. The example is salmon fish, Pacific salmon fish, and also bamboo. I hope you might have studied already about bamboo in your earlier chapters. So reproduce once in a year, the specific salmon fish and bamboo. It is one of the strategy to attain reproductive fitness or to increase its R value. And some populations, they lay huge amount of, huge number of, huge number of eggs which are small in size. And some populations they lay a few eggs which are large in size. So huge number of eggs which are small in size and few number of eggs which are large in size or laid by the organisms to attain the reproductive fitness. So huge number of eggs which are small in size. The examples are like the insects. You can take the example of insects. We can also take the example of fishes, molluscans like pearl oysters can be taken as examples for where they lay huge number of eggs which are small in size. You know, the mosquitoes, the house flies, they lay huge number of eggs, maybe 400 to 450 eggs in a single mating, right? So that is huge number of eggs which are very small in size. You might be knowing in stagnant water there will be huge number of insect eggs laid. So if they may survive or they may not survive because they are more prone to destruction because of the varying abiotic factors and other such factors like predators or pathogens. Next, there are some populations they will produce few number of eggs which are large in size. Like the example is birds. Birds. So they produce few eggs which are large in size. So these are the various type of strategies the populations adopt to increase their reproductive fitness. So the overall view is that every organism tends to reproduce, tends to live successfully in its habitat and to reproduce in its habitat so that it would like to continue its progeny on this universe called as Earth, which is nothing but the reproductive fitness according to Darwin. So for this purpose, they struggle hard, which is called as struggle for existence, and they adopt various variations so that they fit into the frame of the nature, which is called as natural selection. Which is called as natural selection. So this is what is called as life history variations. So this is how the various populations evolve to their maximum capacity to and attain reproductive fitness. So this is the various type of organisms attaining the reproductive fitness. Some of them will reproduce throughout the year, but some of them will reproduce once in a year, and some of the populations will lay huge number of eggs which are small in size, and some of them will lay bigger eggs but few in number. All these can be different strategies of the various populations to attain maximum reproductive fitness. So that is about variation in the this is what is called as life history variations. So in the next class, we'll be taking the topic called as population interactions. We'll be studying about population interactions. So I hope this was a beneficial class. I hope you have understood all of the questions, all of the concepts. So you will be able to answer the questions which are related to this topic, and I hope this was a beneficial class. So I would like to conclude this class. So I'd like to end this session. So stay safe at home, keep learning, and let me end this session. Thank you all.